Today we are going to see and we are going to complete that what is called the polyorganic halogen compounds. This is the last session for this concept. Just you know that we have completed all that gem dihalides, vinyl halides and also polyhalides of methylene chlorides and carbon tetrachloride and chloroform. These are all the polyhalides. Just we have completed that three things. Today we are going to see that carbon tetrachloride, that is 11th standard polyorganic halogen compounds. That is part 3 in video. Part 3 in video. Now this is that polyhalogen compounds. We have completed chloroform. It's completed. Now we are going to see that carbon tetrachloride. That is, we can see carbon tetrachloride. In this carbon tetrachloride, what is the necessary we have to study about this? This is the best solvent and also used as a fire extinguishers. Fire extinguishers. So this is the very important things we have to, and also we can prepare many organic compounds. We can prepare many organic compounds by using carbon tetrachloride. Like even in these preparations we are prepared in many medicines also. That is the reason we have to study about this carbon tetrachloride. Next we are going to see on what are the preparation methods which is given our book. What are the preparation methods? Preparation methods which are given our book. The first method we are going to see here, that is photochemical method. This is nothing but, we can say it is a substitution reactions, which is nothing but we have studied as substitution reactions, which is known as substitution reactions. This reaction which is taking place in presence of sunlight. This photo means light. This is a catalyst. Sunlight is the catalyst for the reaction. Sunlight is the catalyst for these reactions. Now I am going to take here the methane. This is the compound. Methane, that it is treated with a chlorine in presence of sunlight. The reactions, what is called the photochemical reaction, this is to be the reaction taking place under this substitution reaction, and here that H mu is nothing but sunlight. This is, and the sunlight is the catalyst for this reaction. Now we are going to take methane, then plus chlorine. Now this reaction takes place H mu in presence of sunlight. The product which is formed is, you can write this is the reactions by CH3 bondage. This chlorine we can split as Cl bond Cl. Now what happened here, this chlorine react to this hydrogen. What will happen? HCl will be formed. What is the remaining things, you know? There is a CH3 and Cl. This is methyl chloride. Next, the same methyl chloride you have to take here in this second step. CH3Cl, again chlorination in presence of same sunlight. The product formed is called, we can write the same mechanism. The hydrogen is going to replaces by the chlorine, one chlorine, that is Cl bond Cl. Now the product formed is called CH2Cl2, sorry, CH2Cl, CH2Cl2, then plus HCl. CH2Cl2 is called methylene chloride. Methylene chloride. Next to the steps, you can write methylene chloride, CH2Cl2, same substitutions. Instead of one hydrogen, one chlorine is going to substitute. Same Cl2, the same sunlight. The product formed is called CHCl3 plus HCl. Now that chloroform, CHCl3 plus Cl2, same sunlight. That is H mu. We can write H mu. Then sunlight. Sunlight. The product formed is called CCl4 plus HCl. You write now the reactions. You please take now CHCl3 plus Cl bond Cl in presence of H mu sunlight. The product formed is the chlorine with the hydrogen. There is a substitutions. Now the product formed is called CCl4 plus HCl. This is carbon tetrachloride. Is formed. This is that one techniques. The next method which we are going to see, which is given our book, is second method. How do we prepare this carbon tetrachloride? By using the first methods and second method. The second method which is to be given our book is carbon disulfide. That is CS2 plus chlorine, which is giving the product of, you see, carbon and chlorine, which is giving carbon tetrachloride. Then plus the product formed is called S2Cl2. The product which is formed is called S2Cl2. Now in product side there is a 6 chlorine. You have to make into 3 chlorine for the balancing number. Now you see here there is a sulfur, 2 sulfur, there is a 2 sulfur, 1 carbon, 1 carbon. This equation is balanced. This reaction which is taking place in presence of AlCl3, that is anhydrous. This is a region which we are using here in this reaction is, we can write anhydrous AlCl3. Anhydrous AlCl3 is used as a catalyst for these reactions. So now this carbon tetrachloride is formed. In first methods, we can take it as the photochemical. The second method is, that is by using carbon disulfide. The reactant is called CS2, is called carbon disulfide. Carbon disulfide. Carbon disulfide is the reactant. Chlorine is taken. That anhydrous AlCl3 is to be taken as a catalyst. Now the product formed is called. Next to the chemical properties of carbon tetrachloride. Chemical properties. Carbon tetrachloride. The first chemical properties, you know that chemical properties, oxidation, reduction. Now you take for example that oxidation, you know that addition of oxygen. Now you take carbon tetrachloride, then it is treated with water, that is steam at 500 degrees Celsius. The oxidation will carry out. The product formed is called COCl2 plus HCl. Now you see here 4 chlorine, 2 chlorine here, you make into 2 here, 2 hydrogen, 2 hydrogen. Equation balanced. Now you can take for this is called poison. Is a poisonous gas. This formed from this reaction as a major products from these oxidation methods. Next reduction we are going to see here. What is reduction? That you know that addition of hydrogens. Addition of hydrogen. Now you take here the same carbon tetrachloride. Then plus there is hydrogen. You make it 2 hydrogen. This to be the reaction in presence of iron to be used as a catalyst. iron to be used as a catalyst. Now you take into, that is 2 hydrogens. Now the product formed is called, we can write CHCl3 plus HCl. This is chloroform, you know that. Is formed as a major products, chloroform. Next, the reactions which we are going to see here by the same chemical properties, what is given, not given in our book, but it is essential for your NEET examination. Now you take, there is to be the same carbon tetrachloride is treated with, there is benzene, you know that, 2 moles of benzene. C6H6 is called benzene. It's called benzene. Now the catalyst which is used is the same anhydrous. AlCl3 is the catalyst. Now this can split into, this benzene can split into, you should understand the point. The benzene can split into, there is C6H5 bond like, C6H5 bond like, there is hydrogen, there is a hydrogen. These 2 hydrogens are reacted with this chlorine. Now the product formed is called, we can write, that is C6H5 CCl, then the compound which is formed is called C6H5, then plus 2 HCl. Here 2 chlorine and here the 2 hydrogens, all to be, this is 2 moles. Now the product formed is called diphenyl dichloromethane. Diphenyl dichloromethane to be the products is formed as a name. The 4th chemical properties is of carbon tetrachloride. The 4th method, here the CCl4 plus phenol, you know that, it is phenol, then plus there is KOH. That product which is formed is called, this is salicylic acid. This is salicylic acid, and then plus the isomers of para-salicylic acid. This is para-salicylic acid. The mechanism you have to understand here from these reactions. This is that mechanism. How this reaction is carried out. You take phenol. Then plus carbon tetrachloride, CCl4. Then plus 4 KOH. You take now. This 4 chlorine and 4 K. Now the product formed is called 4 KCl. Then what is remaining? 1 carbon is here, and also there is to be 4 hydrogens. 4 OHs, hydroxyl group. This 4 OHs to be approaches to this carbon now, which forms the product of same OH with COH, then plus 4 OH with COH. Then additionally, what is going to be removed from these reactions? You should understand the point here. There should be 1 hydrogen, and here in these 4 hydrogens, 1 to be forms as it here, and remaining these 4 OHs, from these 4 OHs, 2 to be forms as an acid and 2 hydrogen forms as in water, that is 2H2. These are balanced chemical equations. One is called, this all to be called as salicylic acid. This is that very important in this, used in this case of skin disease. What's the purpose of we are preparing this compound? By using this carbon tetrachloride. It is very essential for this and the skin diseases. Salicylic acid is very much important. We are going to see here from these polyhalogen compounds is Freon. Freon is nothing but, it is shortly represented as CFC. It is nothing but chlorofluorocarbon. In this chlorofluorocarbon is that methane derivatives of methane. This is we can shortly represented by this method. What is carbon, hydrogen, fluorine, CBA. C for carbon, represented by carbon, B for hydrogen, and A for fluorine. Now these all, we are giving that value to identify which kind of Freon. We have to give that value for this compound, that is carbon for -1. Carbon we can represented by the -1. Hydrogen we can represented by the +1. Fluorine, that is fluorine. To be, we can take it as such as what is given in the compound. As such as given in the compound. We are going to learn something about this, what is CFC, by knowing the tabular column. And what is the table which we are derivatives? There is a table. First you should go for the formula, number of carbon, number of hydrogens, and fluorine, number of fluorine. And the name of the compound. You take now this formula C, carbon, fluorine and chlorine. Carbon, fluorine, chlorine. Carbon, fluorine, chlorine. Carbon, fluorine, chlorine. Now you take for example CFCl3, CF2, then Cl2. Then for example there is C2F2 Cl3, then C2F3 Cl3. These are all the formulas which we are deriving. From this formula, we have to find out what is that type of chlorofluorocarbon is this. For example, CF, for what is the number of carbon? Actually, this to be valued as -1, this to be valued as +1, this to be valued as such as. Here 3 is there, you write 3 here. Here 1 is there, you can write 1. In this case of CFCl3, you have to write this. What is the number of carbon here? 1. The number we have to take in here is that 1 minus 1 is equal to 0. Here the carbon 1 is present. You write now 1 minus 1. Now it is equal to 0. Now you take carbon 2. There is that point you write 2 minus 1. The value. That is estimated value. Now it is equal to 1. Now there is a 2 carbon. You write 2 in this case. 2 minus 1 is equal to 1. In these cases of this number of carbon, we can represent it as a name for this compound of CFC. Now you take now hydrogens. Here what is the number of hydrogen? No hydrogen. So you write 0 plus 1 is equal to 1. What is the number of hydrogen here? There is no hydrogen. So 0 plus 1 is equal to 1. Now what is the number of hydrogen here? You see there is no hydrogen. So 0 plus 1 is equal to 1. Now what is that hydrogen here? That is 0 plus 1 is equal to 1. What is the number of fluorine here? 1 fluorine, 1 fluorine. What is the number of fluorine here? 2 fluorine. What is the number of fluorine here? That is 2 fluorine. What is the number of fluorine here? 3 fluorine. So what is the value here to be represented? That 1 and 1 is represented. So this is known as Freon 1, 1. Now what's the value represented here? 1 and 2. So now this is Freon 1, 2. And what's the value represented here? 1, 1, 2. Now this compound is Freon 1, 1, 2. What's the value represented here? 1, 1, 3. So it is called Freon 1, 1, 3. This is to be the methods of naming for the case of freons. This is the tabular column. We have to derive this. What kind of freon is this? This is trichlorofluorocarbon. This is difluorocarbon. This is difluoro-trichlorocarbon. This is trifluoro-trichlorocarbon. In these cases, we have to identify Freon 1,1, Freon 1,2, Freon 1,12, Freon 1,13. This is the kind of that compounds of Freon. And what is the necessary we have to study about this Freon? The Freon is the best refrigerant in refrigerators and air conditioners. And that is the reason we have to study about this Freon. And before that, we are going to preparation. Method of Freon. I am going to prepare this Freon by using the first method, carbon tetrachloride. Then plus 2 hydrogen fluoride is a major component. And here what's the catalyst? Stibbium pentachloride. Then it gives the product of, there is a carbon, there is a fluorine, there is a chlorine. So you write CCl2F2. Then plus, what is here? 2HCl will be the products. This is the first techniques. That is, we are going to prepare by using the catalyst, what is Stibbium pentachloride. The second method which we are going to see, the same carbon tetrachloride plus stibbium fluoride, SbF2. Then the same catalyst, stibbium pentachloride. Now the product which is formed is called, we can write C, there is carbon C, there is chlorine, you write Cl2, there is fluorine, you write F2, then plus, we can write what is the compound which is present, stibbium chloride, BCl2 will be the products. Here this is the Freon. So now you see there is a Freon, 2 fluorine is there, and here there is no carbon. That is the point you should write here. There is 1 carbon, no hydrogen. Now in this case you can write Freon 1, 2. This is to be called as, we have given here that you see CF2, Cl2 is called Freon 1, 2. This is also Freon 1, 2 is the compound which we are preparing. Next, what is the chemical properties of that Freon? And here the chemical properties is to be not listed in our book. And just we are going to study about this, what is the physical properties. Generally the physical property is nothing but, and its states we are going to understand about. And here the Freon is the best stable compound. So what are the physical properties which we are going to see here? Physical properties. The first one, it is a stable compound, highly stable. It is a stable compound. It is the Freon which is used as a refrigerant in refrigerators and refrigerant in air conditioners. This is a very coolant material of CFC, you know that, in this fast growing world. And propellant in this aerosol and the foams. Foams is nothing but it is a froth. And propellant for the foams to be spray out deodorants and also shaving creams and also insecticides and also perfumes. This chlorofluoro only carbon has to be used as a propellant. This is the major uses of this CFC. That is the reason we have to study about the CFC. Next we are going to see here that the concept of DDT. What is called DDT? DDT is nothing but dichloro, diphenyl, trichloroethane. This is the first invented by the discovered by the Paul Muller. Discovered by the Paul Muller. Here, this is the first compound which is synthesized in laboratory as an insecticides, that is chlorinated insecticides, and that is the reason which was awarded Nobel Prize in the year of 1948. So how to prepare this DDT? That is preparations methods. Now you take it trichloroacetaldehyde. Now it is treated with diphenyl. There is a 2-phenyl compound we have to take, that is chlorobenzene. We have to take 2-chlorobenzene. This is chlorine, this is benzene, so chlorobenzene. The benzene ring which containing, that H, CH, 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 C, CH, the concept. Here also C and H, these two hydrogen reacted with oxygen in presence of concentrated sulfuric acid. Now that product formed is called, that is minus H2O. The remaining things are present is what you can write, C, Cl3, then CH, that is CH, then with diphenyl. You see, dichloro, diphenyl, trichloro, 3 chlorine is here, trichloro. Here one carbon, here one carbon. But 2 carbon is there, it is ethane. So that is the reason I have named as dichloro, diphenyl, trichloro, ethane is the compound. That's all. This is the preparation methods. What is the necessary we have to prepare? This is also used in this advanced medical science. It is the pest control and insect. DDT, especially we are manufacturing by these laboratory methods. That is, and what are the uses of DDT? Which control the insects which are carrying diseases like malaria and yellow fever. This is control these insects, insecticides. And here, in agricultural farms, in agricultural field, that it controls many pest, pest and insects. And here for these building constructions, in basement of these building constructions, we can control this pest, and we can use as a pest control, and which all kills various insects like housefly, mosquitoes. These are all the very dangerous to the human being, which are carrying many diseases and which are giving more disease to the human beings, and we have to kill by using DDT, and which are highly specific in its toxicity. The toxicity is nothing but it is highly poisonous. But these are all the uses, and that is the reason we have to study about these all the uses of DDTA. And you please learn this point what you have seen today, and just we have completed that all portions of polyhalides from these 3 videos. You please watch these videos and learn more points, and you have to understand that concept of polyorganic halogen compounds, and you please learn. This is very important in this case of synthetic field and also laboratory field and also in forthcoming medicinal field. You please learn more point. You get this more understanding points. Thank you. We will see on